Awesome. Well, hi, everyone. Let's get started. Welcome to Unity Catalog Managed Tables. My name is Sirui. I'm a product manager here at Databricks. I'm joined by Cindy, who's another product manager, and we work in the storage and Delta Lake space, and we're here to talk about how, with managed tables and Unity Catalog, we're delivering three things simultaneously: powerful, easy, and interoperable tables. So, first off, what is the challenge? The challenge, which we hear all the time from almost all the customers we talk to, is that as they move to the modern data lakehouse, they have three simultaneous requirements for their data. The first one, I think the most important one, is that their data is open and interoperable, right? They want a single copy of the data in an open format to which they can bring the right tool for the right job. But on top of that, they want to make sure that this data is highly performant, right? It can't just be CSV sitting in a bucket somewhere. The idea is that this data is terabytes, sometimes petabytes. It's used for mission-critical purposes, and so how do you make sure that data is highly, highly optimized, has the best price performance possible? And finally, they want all of these properties while at the same time not requiring a team of data PhDs to chase after all of the exploding number of use cases and new workloads. Because if you do that, you're just forever going to be playing whack-a-mole. So raise your hand, by the way, if y'all are facing some of these challenges today. Okay, came to the right place. So basically, in this talk, we're going to show you how the data intelligence platform comes together to enable managed tables that meet all three of these criteria, right? Open, fast, and easy to use. And what we're going to do is we're going to start at square one. We're going to talk about what are managed tables and how are they different from external tables. And then we're going to approach managed tables from first principles. We want to give you a peek inside the thinking of how and why we design managed tables the way that they are. And that's going to give you a bit of a theoretical foundation for when we talk about their benefits: how they're open, how they're interoperable, how they're performant and easy to use. And then finally, because it's Data and AI Summit, we want to give you a sneak peek at the roadmap where we're headed with managed tables. All right? So to start, let's begin from square one. What are Unity Catalog managed tables, and how are they different from external tables? So managed tables, there's two types of tables in Unity Catalog. There's managed and external. When you create a table, by default, it's a managed table. So if you just do create or replace table, give it a name, write a query, that is a managed table. And when you do this, the table gets created in a storage location that is Unity Catalog managed. So you give us a storage location, either at the catalog or schema or metastore level, and we will create a table in that storage location, and Unity Catalog is going to manage how the data is laid out and placed within that bucket. Now, in contrast, you can create an external table. And the main difference is, with an external table, you define a specific location in which that table lives. This is more specific than what you did before, right? Before, you're just giving a bucket at the catalog or schema or metastore level. In this case, you are giving us a specific directory in which the table lives. And that's an external table. So you put those two side by side, we can do a comparison. Now, with all of these table types, with both of these table types, they're going to be open, right? They sit in storage that you control in the open source Delta Lake format. And they're also going to be interoperable. The idea being you can bring any tool you want to the job, and we'll talk about how that's the case. But the big difference between the two is that with managed tables, we're going to bring the data intelligence engine to bear against your data, and we're going to be able to optimize your data and do a bunch of automated management to give you better performance and ease of use. And so, if you think about it a little bit, you might ask, why would we build it this way, right? Why is it the case that if you tell us a specific directory for a table, that table is an external table, and then we can't do the data intelligence stuff on it? Or put another way, why not just apply the data intelligence stuff all the way across the board for all table types? Well, to do that, we got to go to first principles. So in 1970, computer scientist E.F. Codd wrote a seminal paper titled A Relational Model of Data for Large Shared Data Banks. This paper is really credited with inventing the relational model, and he set out a bunch of the core timeless principles that underpin the designs. So this included the idea of data independence. So he noted at the time that a key problem with a number of systems was that you could not change how the data was laid out without changing the code that was built on top of those systems. So in other words, if you change how you store the data, your code breaks. So solving this challenge is the case for what we call data independence. When you change how your data is laid out, we want it to be the case that your application logic should not have to change, that the two are completely abstracted away from each other. And so to illustrate why this is super duper important, let's look at some code. So on the left here, we have data dependent code, something we want to avoid. This is Python code that parses a CSV. So you'll notice the code is deeply intertwined with how the data is stored, right? It assumes, for example, that the department name is in the third column, that salary is in the fifth column, commas are the delimiters, et cetera, et cetera. And the problem with this code is that you have no flexibility to change how this data is laid out without changing the code that depends on it. On the right, we have some SQL. This is completely data independent, right? This code has no dependency on how the people table is laid out, and you can iterate on the underlying storage format to your heart's content. And so it's hard to argue that the code on the right is clearly better for all involved, right? Because it allows for the underlying storage formats to incrementally improve over time, while your application logic doesn't have to change. And so we've made a lot of progress in the Lakehouse over the years towards more and more data independence. So back in the data swamp days, when you were using either Parquet or CSV or whatever, there was a lot of data dependence that you had in your code. Your code had to reason about, well, what files do I go look at? How do I reason about the schema across those files if they're different? How do I reason about concurrent writers? And even with Delta 1.0, we made a lot of these things independent or more independent. So your application logic, just even using basic Delta, does not have to worry about things like which files to go and get to, because the Delta log takes care of that. It doesn't have to worry about rationalizing the schema across those files, because Delta takes care of that. However, what we found with still is that this is not fully data independent. And that's because a lot of customers were still taking a dependency on paths. And so for this toy example, we have pretty common code. You're just doing select star, and you're pointing your code to a Delta table at a particular path. So you have a client, and you're telling it, go to that specific path. And the way Delta works is the client is going to expect at that path a Delta log, which is the transactional source of truth, and the Delta log points to your actual data files in Parquet. So what's wrong with this? Because this seems pretty reasonable, right? Well, it turns out this pattern, being not fully data independent, causes a number of issues. Here's our first example. You don't get fine-grained access control in this model. So suppose you want to take this table and you want to add either row or column level security so that clients only get access to a subset of the data within the table. But what you do in a pattern like this is you give IAM access to the entire directory for this client. And that means this client gets access to all of the data in the table. And so it's really difficult to securely offer row or column level security. This pattern also results in a number of what we call landmines, subtle problems that only become evident at scale in production. So here's one example. You have two clients, they're writing to the table. The client number one, it starts executing a really complicated, expensive merge command, referencing the table by path. And while that command is still executing, client two goes ahead and it does a drop and create on the same path. This is also a pretty common pattern. But since this command is probably a little bit faster than the merge, it finishes first. Blue client finishes first. And so what happens is that client one, when it finishes the merge command, it's actually writing to the wrong table. It's writing to this new table, not the table that I thought it was writing to before. And needless to say, that's really bad, right? It results in subtle bugs, potential data loss and corruption. This is the type of issue with data dependence that can really only happen, that happens at production at scale that we want to avoid. Finally, here's a third challenge. So with Delta, we're seeing a proliferation of clients with various capabilities. So many Delta clients are pretty modern. They're able to use the latest and greatest Delta capabilities like deletion vectors and liquid, but many are not, right? They're out of date. They expect Delta version 1.0. And that's just a characteristic of any dynamic and evolving ecosystem. But the problem is if both of these clients are statically pointed to the same exact path, right, you're faced with a difficult choice because both clients are expecting the same Delta log and the same Parquet files. And that means that you either keep your Delta table on the lowest common denominator in terms of features, in which case you're leaving a lot of performance and capabilities on the table, or you upgrade those Delta tables with the latest features, but in that case, you might risk breaking the legacy clients and breaking the users that rely on them. So Those are some of the challenges with path-based access to Delta tables, and it motivates why we want to achieve full data independence in the lakehouse. And so the way we do this is that instead of hard-coding static paths to tables, you go through an open catalog. The catalog directs clients at runtime to the correct locations, and you get full data independence. So what does that look like? Let's return to our toy example. But now you have a client, you have storage, and you have a catalog. And the code inside the client references a table by name, by the catalog name, not by path. Right? And so it talks to the catalog. The catalog then returns at runtime the path to the table. So why is this better? Why is this better? Well, this is full data independence. One thing it lets you do is fine-grained access control. Right? So before, you gave access to the whole directory. In this world, though, what the catalog can do is that it can hand back the paths to the files that this client should have access to, and just those paths. And furthermore, it can hand back finely scoped credentials so that the client only has storage level access to the files that it should have access to. Fine-grained access control. The second case, so let's revisit the table collision case that we talked about before. And let's see what happens now with the catalog and with data independence. So in this world, client number 1 runs the merge. The catalog tells it, oh, this is the table in orange that you're supposed to talk to. Now, while that merge is running, client number 2, again, does the drop and recreate. Now, first of all, the catalog tells it, oh, go and drop the table in orange, the one on the top left. But when it creates a new table, the catalog understands that it should actually go and create a different table. These are 2 different tables. And so client 1, when it's done with its command, it goes back and it writes to the original, the orange top left one. So first of all, it's not clobbering the blue table, which it did before. And second of all, it's able to have a friendly error message now to say, hey, you're writing to a drop table. Finally, modern clients and legacy clients can talk to the catalog and be treated differently. Right? So the catalog can be told that different clients have different capabilities and levels of support. So a modern client talks to the catalog, and the catalog realizes that it's a modern client, and they can get a version of the table with the latest metadata and data bells and whistles. But a legacy client, similarly, can talk to the catalog, and maybe the catalog realizes that this client needs a slightly different version of metadata that it's capable of reading. Or the legacy clients may go directly still to hard-coded paths in cloud storage, in which case, similarly, you can make sure that at least in that path, there's a legacy version of the table. We'll talk about this more in a second, but this is just an example of the type of capabilities that we can achieve with data independence and that we want to achieve in managed tables. So this is why managed tables are built the way they are. When you create a managed table, you get data independence. Right? Unity Catalog manages a storage location, and it makes sure to understand how the tables are laid out and stored, and it provides that layer of indirection. And in doing so, this unlocks all of the capabilities that we're about to talk about and avoids the landmines that we discussed before. And in contrast, when you create an external table, you are back to data dependence. Right? You're saying, in a specific location, therein lies the entire table. And so you're locking yourself into that level of data dependence. Okay. That's all the theory we're going to talk about today. Let's shift gears and talk about how Unity Catalog tables are designed to be open, fast, and easy to use. And so AI assets, the first topic is interoperability and openness. And so all assets in the data intelligence platform are built on an open foundation, right? An open data lake at the bottom there, on top of which rests your data in the open Delta Lake format. And Unity Catalog tables are no exception. So all UC table types are open and interoperable. And just like external tables, UC managed tables continue to live in cloud storage that you own and control. And you'll see this. When you create a catalog or a schema or a metastore in Unity Catalog, we ask you, hey, what storage location do you want to use? And you just give us a bucket. And that's a bucket that you own. In addition, all UC managed tables are in the open source Linux Foundation Delta Lake format. So that's an open format with a wide connector ecosystem. And side note, thanks to Delta Lake Uniform, not only are these tables accessible as Delta Lake tables, but also as Hudi and Iceberg tables. Okay, so what that means is you can bring the entire Delta Lake or Hudi or Iceberg ecosystems to bear on a single copy of your data. However, in order to make interoperability work with your data, while preserving data independence, it's important not to direct your clients directly to the path where these tables live. Because if you do that, then you're back to the pitfalls of data dependence and all of the landmines with it. And so we want interoperability, but we also want to preserve the governance that comes with the Unity catalog, and we want to preserve data independence. And so how do we do that? So let's talk about interoperability. The challenge here, of course, is how do you take the data that is in UC managed tables and access it from tools outside of Databricks, right? Because we 100% want that. We think that's a non-negotiable building block for the Lakehouse. The first method, of course, is that we have ODBC and JDBC connectors for Databricks clusters and warehouses. So any tool that supports connecting to these protocols, you can connect them to Databricks Compute, where you'll get governance from Unity Catalog, you'll get great Databricks performance. And that's a super common way to connect, for example, business intelligence tools like Power BI and Tableau. But of course, we want ways to connect to the data without going through Databricks Compute. Because if that was the only way to do it, this wouldn't be very interoperable or open at all. And so the second method is delta sharing. So delta sharing is an open source protocol where a single copy of delta tables can be shared from providers to consumers. And the idea here is the delta sharing protocol uses a sharing server. And this sharing server provides clients with secure access to the underlying storage where delta tables live. So you still have one copy of the data, but you can take any client which supports a delta sharing connector and point that to your data. So we've open sourced both the delta sharing server and a variety of clients. And within the Databricks Data Intelligence platform, we run a version of that for you automatically, so you don't have to run it or maintain it. All of that is tightly integrated with Unity Catalog. And delta sharing is really powerful, especially powerful for organization to organization sharing. So within the Databricks Data Intelligence platform, we have a number of additional capabilities layered on, which are really great for those kind of use cases. These are things like extra security through IP access and cloud region restrictions, the ability to share specific partitions, and a really easy to use UI. But we're not done just yet, because our final goal is to enable full read-write access to UC managed tables from the entire ecosystem of Delta Lake, Iceberg, and Hudi. And there, we have a really, really exciting announcement coming on the Thursday keynote, where we will talk more about how we are making this a reality very, very soon. I wish I could tell you more, but that's a secret until then. But you can come back to this rerun, and we'll talk more about it then on Thursday. All right, with that, I'll hand it over to Cindy to talk about how UC managed tables are powerful yet easy.
Mic check. Thank you, Sirui. Hi, everyone. I'm here to tell you more about how UC managed tables are not just open and interoperable, but also powerful and easy to use. And in particular, Databricks will handle every aspect of the complete data management lifecycle for you. From making sure that tables are performant and scalable at table creation, to fine-tuning your data layout with our AI-powered capabilities to give you the best price performance, and lastly, making sure that storage is properly managed even after you drop your table to maximize your storage cost savings. And first, let's see how UC managed tables are performant and scalable at table creation. So coming soon, UC managed tables will be automatically updated with the latest Databricks innovations. And to motivate the problem a bit, let's see what are some of the examples of the recent Databricks innovations. First, we have row-level concurrency. So the challenge here is, historically, if you had concurrent operations running, they could conflict with each other, and the winner would succeed, the loser would return with an error, and you had to do a retry. And the best way around this is to partition your tables because you don't run into concurrency issues across the partitions. Or you have to code defensively on top of your code for retry loops just in case things fail. And either way, this results in a lot of complexity for the end users. But with row-level concurrency, we make this way simpler by automatically resolving the concurrent transactions at the row level when writing to UC managed tables. You no longer have to rely on partitioning or concurrency or designing workloads to avoid conflicts when writing to a UC managed table. Up next, we have column mapping. So historically, when columns are deleted or if there's a name change, the data files have to be rewritten, which could be expensive. But with column mapping, we enable metadata-only changes to mark columns as deleted or renamed without any data rewrite to your files. And last but not least, we have deletion vectors. So traditionally, when users have to use copy on write or merge on read to process DML operations, the prior makes writes very expensive, while the latter slows down reads. Deletion vector is our storage optimization feature, which allows for the tracking of deleted rows. The feature can significantly speed up merge, update, and delete queries with no performance compromise on reading the queries. So I'll pause here for a second. So raise your hand if you're absolutely sure that you have all these 3 innovations enabled in all your tables across your Databricks deployment. I see a few hands in the room, and this is exactly the problem. The challenge is that we have so many innovations, but it's so difficult to pick up. And actually, it's a problem we see across all the lakehouses and across all the table formats. People are stuck on V1, and it's difficult to pick up the latest features. You have to manually find and update tables with the latest Databricks innovations and repeat this for each and one of your tables as your data grow. But with automatic Databricks updates on your UC managed tables, you get the latest innovations with just working out of the box with no work required from you. And all this just means that UC managed tables really makes Databricks simple to use. You no longer have to worry about playing catch up. And coming soon, we have a few more exciting features that will be enabled by default. First, we have the variant data type, which improves performance on processing unstructured data by up to 10 times. We'll also have automatic type widening, which widens data types automatically when there's a data type change on your schema without any data rewriting. And last but not least, we have liquid clustering. This is a customer favorite and one of the fastest adopted features on Databricks. And once enabled by default, it can really speed up your query performance. And once again, we'll automatically update your UC managed tables with all these features when they're ready. And rest assured, you can just set and forget your UC managed tables at table creation. And you're perhaps wondering, what are the effects of always getting the latest Databricks innovations? So from our internal benchmarks, where we incrementally ingested and clustered data from an industry standard data warehousing datasets, we see that tables with the latest Delta innovations can actually achieve 7 times faster write times than the tables without. And up next, let's see how we harness the power of AI to fine-tune your data layout without a lift of your finger. We all know that proper table maintenance can improve query performance and cost efficiency a lot by optimizing the lakehouse for your organization's unique needs. However, getting this right requires a lot of technical expertise, manual overhead, and continuous adjustments. And folks here can probably relate to some of these questions on the slides. So as data engineers, you constantly have to be figuring out what optimizations to run, which tables you should be optimizing, and how frequently you should be running these commands. And once these questions are answered, you're not done yet. You actually have to manage the operational overhead of actually running these optimizations, such as through scheduling jobs, looking through failures, and even managing the underlying infrastructure. And this is not just a one-time setup. With your data growing, you must continuously update these jobs when new tables are added or when your query pattern change. And as the data and AI use cases have exploded over the past few years, we've heard so many customers complaining that they're just not able to keep up with optimizing their tables because of the expanding business needs. And here comes predictive optimizations, which solves all these data management problems for you. And actually, as of today, we're proud to announce the general availability of predictive optimization. So how does this work? Predictive optimization can intelligently decide the schedule of optimizations to run by leveraging Unity Catalog and our data intelligence engine. Our AI model can take into considerations of your query patterns and combine that with the factors such as data layout, table properties, and performance characteristics to determine the most impactful optimizations to run. And then, predictive optimization can learn and adapt to your data access patterns. Our data intelligence engines can learn from your usage patterns over time and make sure that your data is always stored in the most efficient layout, translating to cost savings and performance gains without any manual intervention from you. But it doesn't just stop there. Predictive optimization actually goes in and runs these commands on your behalf through spinning up serverless infrastructure. It prioritizes the table to run based on the return on investment. So it really is trying to understand which tables can benefit the most from these commands and make sure that it actually balances it out with the cost of running these operations. And by taking advantage of data independence, as we heard from Sirui earlier in the talk, predictive optimization has the latitude to perform more powerful optimizations. And currently, with predictive optimization in general availability, we support the following commands. First, we have compaction, which improves query performance by optimizing on the file sizes. We also have liquid clustering. It clusters the new data that comes into your table incrementally. We also have vacuum, which improves cost efficiency by deleting unneeded files. And since the public preview, we saw tremendous adoption for predictive optimization. We have over 1,500 active customers using predictive optimization. We have more than 5 exabytes of data under management. And on some days, we are even optimizing more than 2 petabytes of data a day, which is truly phenomenal. And you don't have to just take our words for it. Predictive optimization has been endorsed by so many customers for its simplicity to use and the benefits that it brings. So customers like Anchor have reported that we are able to save them 50% in annual storage cost and speeding up their queries by 2 times. While some other customers really like how predictive optimization is an autonomous system and can fully replace manual solutions, such as the team at Toloka AI, which is an AI data annotation platform. They've spent so many hours just trying to identify the most important tables, try to monitor their data, and figure out what optimizations they can run. But as soon as they tried out predictive optimization, they were able to retire their do-it-yourself solution because our out-of-the-box maintenance operations just completely solved their use case. And we also heard from the team at Plenitude, a large energy company, where they saw significant storage cost benefits soon after enabling predictive optimization. But we're not done yet. Even though predictive optimization has G8 as of today, we're constantly innovating it to make it better and better for your UC managed tables. In particular, we have 2 new exciting capabilities to share that are in private preview. First, we have AutoStats. So as of today, you have to run analyze on your tables to collect query statistics. Again, similar questions you have to answer. Which tables to run analyze on and how frequent to do so. And guess what? This is actually one of our least run operations because it's just so manually intensive to keep track. But with AutoStats, predictive optimization can now collect query optimization statistics during supported write operations. And in fact, collecting these statistics during ingestion is actually more efficient. The time it takes to write new stats during ingestion is actually 20% faster than running analyze as a standalone operation. Predictive optimization can then intelligently update the stats used to optimize queries by running analyze in the background. And again, these operations are run only as necessary, determined by the smart logic we have to track when the stats are stale and are needed by the workload. And the feature's net result is your queries are just going to get even faster with predictive optimization. And if you're interested, chat with your account team today to get onboarded. Up next, we have automatic liquid clustering column selection. This one we're super excited about and will announce private preview very soon. By simply running create table cluster by auto, predictive optimization can come in and choose the liquid clustering columns for you. The challenge with liquid clustering is you still have to choose the clustering columns today. Even though this is a lot simpler than partitioning, it is still something you have to think about. But now with predictive optimization, we think we can actually automate this choice by looking at your query patterns and the queries and the columns you often query. And we can do an amazing job by choosing the clustering keys for you. So how does this work? First, we collect the query scan statistics. So these include query predicates and join filters by determining if the table will even be benefited from adding or changing the liquid clustering keys. And then we model the workload to understand and identify the eligible columns. We choose candidate clustering columns by looking at the query workload and identify columns that can provide the maximum data skipping across the entire table. We then estimate the potential savings for each column across all the scans and rank the top candidates. The savings calculations are based on the scan queries in the past 30 days that could optimize for reducing the data read across your entire table for all the queries. And finally, once the new clustering key candidates are identified, our heuristics will calculate if the benefits of applying this set of new keys to your table will actually outweigh the cost of changing keys. And if the new set of keys yields significantly more benefit than the old set of keys, here we are really making sure that's actually a positive return on investment for changing keys on your table, because we know that clustering could be an expensive operation. Then predictive optimization will actually go ahead and change the clustering keys on your behalf for your UC managed tables if it's a positive return on investment. So the capability in a nutshell, we choose liquid clustering keys for you such that the benefits from data skipping can outweigh the cost of clustering. We'll launch private preview very soon, and we're actively recruiting for customers. Please reach out to your account team to get onboarded. We think this really is the future for a completely hands-off data layout management. And for predictive optimization, we're constantly making heuristics improvement to make sure it's getting smarter and smarter for your UC managed tables, and to determine when and what we can do to optimize your UC managed tables with the power of AI. And last but not least, we accompany your data all the way to the end of your data lifecycle journey. And here comes automatic file deletion after you drop your table. Now with UC managed tables, whenever you drop your table, Databricks will automatically delete the files for you. This is still within your control, as you'll have a 7-day undrop period to keep your table. And some exciting new capabilities coming soon. You'll be able to configure the undrop period if 7 days is not what you're looking for. Or you can even use the delete now capability to accelerate the file deletion. And now, I'll pass it back to Sirui to tell us a bit more about what is coming next.
All right, mic check. Yell. All right. Can y'all hear me okay? Oh, there it is. All right, so because this is Data and AI Summit, I wanted to give you all a sneak peek at what's coming up next for UC Managed Tables. We have a really exciting roadmap, and actually 7 minutes is not going to be enough to give it justice, but consider this a trailer. So first off, in terms of interoperability, one of the things we're really, really excited about is what we call seamless support for legacy readers. So the idea here is, we mentioned before, this challenge where you have the latest table features that really speed up table performance and make tables easier to use. But the downside is you may have out-of-date legacy clients that are not able to read those capabilities. What we are working on right now is the ability to use a uniform-like technology where we can generate for a very modern table the correct metadata for out-of-date clients. The correct data and metadata for out-of-date clients. And those clients can be pointed to that set of metadata. And so it can actually read all of the latest tables. Right? So that means that even the most up-to-date tables can be read by even the most out-of-date readers. And so with this, we hope to put a permanent end to this phenomenon of all tables being stuck at version 1 just for the sake of compatibility. Second, observability. So one of the biggest feedback points that we get from UC managed tables is that it's really great that they are data independent, but what it means is it can be a little bit more difficult for you to introspect within your storage what all tables you have, what are the size of those tables, and things like that. And so this is a big area of investment for us. The first one here is predictive optimization. So predictive optimization, what Cindy talked about, already has an out-of-the-box system table you can use to understand what all it's doing. So what operations it's running, What benefits is it giving you, et cetera. One of the things we're working on that we're super excited about is an out-of-the-box dashboard built on top of that system table so you can see all that information just a little bit more easily. We're also excited to be working on a Delta table system table. So the idea here is for all your UC managed tables, we're going to generate a system table out of the box, which tells you everything you need to know about those tables without you having to go to cloud storage. And so the idea here is, for example, you can use this table to query for, well, what are my largest Delta tables? How is the size of my tables changing over time? Or maybe look at, the largest tables that no one's really queried in the last 30 days. So we want to make that just really sing out of the box and make looking at S3 inventory logs a thing of the past. And finally, as we heard from Cindy, we're just continuously working on more capabilities to improve how your table's data is laid out for better price performance. So in addition to things like liquid clustering, automated liquid clustering, we're also working on things like automated compression. So taking your data that you don't use very often and compressing it for lower costs. It includes things like automated archival. So can we automatically archive that same data to colder tiers of storage? And finally, it includes something like automated TTL. This is a really commonly requested use case for us where you might say something like, hey, for any row where timestamp is greater than 90 days old, just go ahead and delete that and vacuum that for me. So the idea here is that your data in UC managed tables is just going to get more performant and cheaper automatically over time. And with that brings us to the end of our talk. If there's one thing to take away, it's that our goal for Unity Catalog managed tables is always going to be, 1, open and interoperable, 1 copy of data against which you can bring any tool. 2, to make them more and more performant over time. And 3, to keep them being easy to use. So a hands-free experience, but one where you can easily observe everything that's going on within the environment. And to get started today, all you have to do is create the tables in UC managed tables. In fact, the way to do this is as easy as possible. Just don't specify an exact storage location for your tables and you're all set. So with that, thank you very much. Appreciate you all coming.